So this is 2018 paper 2 question 1. So we have an experiment consists of throwing 2 fair standard 6-sided dice and recording the sum of the 2 numbers thrown. So some of the totals are shown in the table below. So complete the table. So we know that in order to complete the table, it's the sum of those scores. So you can see 1 add 1 is 2, 2 add 2 is 4, and so on. So what I'm looking to do here is 4 add 3, which is 7. I'm looking to do 2 add 5, which is 7. 1 add 6, which is 7. 4 add 4 here, which is 8. 5 add 5, which is 10. And then we have 6 add 6, which is 12. So we can see there's a diagonal relationship there. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And just double check that before you move on. What they're asking you in part 2 then is to find the probability of getting a total of 7 or 11. So for 7, there's 1, 2, 3, 4, 5, 6. And for 11, you have 1, 2. So that's 6 add 2, which is 8. So because they're asking you for a probability, well, we have 8 possible outcomes to choose from out of all of the possible outcomes which are here. So 6 times 6 here is 36. So we can also simplify that then, and that is 2/9 because they're both divisible by 4, and you can use your calculator to do that bit. So for the next bit then, they are asking you to find the probability of getting a total which is a prime number. So prime numbers are 2, 3, 5, 7, and 11, because these numbers only go as far as 12. And prime numbers are numbers that are divisible by itself and 1 only. So for the 2's, we have 1. For the 3's, we have 2. For the 5's, we have 1, 2, 3, 4. For the 7's, we've got 1, 2, 3, 4, 5, 6. So all I'm going to do there is I'm going to add them together. And for 11, I have 2. So now I can add them together. So that is 15. And again, they're asking you for a probability. So that's 15 out of 36. Okay, and you can simplify that again. So 3 goes into 15 5 times, and then 3 goes into 36 12 times. Okay, so that's 5 over 12. They'll accept 15 over 36 as well. So the second way of answering this question is by creating a two-way table, and you can see here that when you're answering this question here, you have 18 Ford cars out of 30, and all I did was here, I knew 7 were red, that means 11 of them were not red out of the 18, and I knew that 4 were red in the Renault out of the 12, leaving me with 8 that are not. So when they're asking you what is the probability of the car chosen as the Ford car, so there's 18 of them in total out of 30, and then or a car which is not red, well, you can see the ones that are not red that are left are 8 here out of 30, which gives you 26 over 30, which is 13 out of 15. That's just another way of solving it. So another way that you can solve it then for the same question is that you know that there's 18 that are Ford cars, and then how many of them are not red? Well, you know that 7 add 4 is 11, so that makes it 19 that are not red. But then you don't want to include the 11 cars which are Ford cars. So you want to include those, so take those away because they're being counted twice. So these are the 11 cars that are Ford cars that are not red because they're being repeated twice because they're already included in that 18 to 30. So that's why we need to take that away. And that's why you'll end up with 26 out of 30, which is 13 over 15. It's just another way to answer the same question.